What's up YouTube, this is Jacob, and today we're going to be working on this 2015 Smart car. This is a company car that we use to drive around to local shows, things like that, and a lot of times what we take is small, but sometimes we have two people, so it'd be really nice to get some of the luggage outside of the vehicle, and we thought we would make a luggage rack similar to the factory bike rack that Smart sells, or Mercedes, whoever. And the way that is you take the essentially the tow hook mount, which threads into the bumper here. You thread in some, you match the thread with something like a threaded rod. We'll just say this for example. So you thread that in and then mount whatever you want onto those threads, right? Just basics, simple, something simple like that. So we took this old, whatever it was, a shoe rack or something that I garbage picked, found it in the garbage, I cut it in half, and we were gonna make inserts like that, and then there's our luggage rack, right? Something super light, it doesn't weigh anything, and the things that we would put on it also shouldn't weigh anything. The factory bike rack says something like there's a limit of 30 pounds on it. I don't know. But anyway, the project didn't work out. I can't cut the threads on this lathe. It's just not strong enough, or I'm not going to say it's not strong enough. We could do it if I had all day. It would probably take me all day to do. I just don't feel that it's worth that for what it is and really what we could put onto it. But I'm going to list this project because there's some interesting things, or somebody might find it interesting, and more or less the discussion on the the tow hook mounts themselves. There's a lot of debate, I don't know, and then I can express my opinion on it. But let me bring you in closer on that, and we'll get going. And again, don't feel like you have to watch everything. I put a time lapse on me making everything, and I'll annotate it, but really just wanted to post it for just more or less a discussion. But thanks for watching. On the back of the Smart car, there is these spots for the tow hook, and basically what it is, what's behind there is there's a metal threaded insert into the sheet metal bumper and a little knockout for essentially that you could easily pop out, and here's the other one with the knockout in it. And essentially all you do is thread in the tow hook to that and pull your car out. And let me give you the shot of the tow hook here. So this is the tow hook, and what it is it's not really an Acme thread, but it's close. It's more of a rounded Acme thread on it, and the only reason I can think that it's rolled is so that they don't have to have sharp corners on the tap for the insert. So the more round that they can make both the crown and the trough, the looser the tolerances are going to be. And the idea is that you just take the tow hook, thread it in, and essentially use that to pull the vehicle around. Now, because there's two of them, they sell a bike rack that essentially uses a mounting point on both of these, and then that holds the bike rack up. And you can see, I mean, I'm pushing this car around, and it's pretty strong. But so that was the project. Essentially what we have here is this old, I don't even know what it is, I garbage picked it, some shoe rack or something. And I cut it in half, and then each half here would sort of lay down, and we could make some things for it. But essentially, just like the bumper hitch racks, that would just screw into the tow hooks and hold whatever. So there's a couple problems with this project. One being this is an Acme thread, which is really meant for loading, well, I guess axially and not radially. And also from the bending moment of coming up and down on a luggage rack or a bike rack, the major concern is that this welded insert is going to fatigue right at the weld for the sheet metal and tear out. And what we're looking at here is, this is the back tire, this is the back fender. Over right there is the insert from the back of the bumper, and you can sort of see my finger coming through the hole there. And then this piece here is the sheet metal, formed sheet metal part that the insert would be welded into on this piece of sheet metal here, this curvy piece. So you can see all these welds here. You can see, probably can't see in this picture, but on the front of this piece here, it's that insert's welded right around the front. So the concern would be that all of these welds would fatigue from stress, because they're really not made for cyclic loading like what would be on there from a luggage rack. But this whole bumper support is bolted on. I mean, if you really wanted to, you could come back in here and weld it, get some more welds back in this section here. You could maybe make a longer insert and then a backing plate that would weld to the back of the bumper. I mean, there's ways to do it, if you really wanted to and have time and everything. You really could make something that could support it. So I've got you in kind of a weird angle here, but you can sort of see this would be the insert, and then right along all around it is sort of a fillet weld there. But the tow hook just goes in, and I want to show how easy it is to thread in, because there's some debate on what this thread is. So this is in there, it's loose, it's not binding. It's not binding at all, it's going in easy. Same level of tension going all the way in, right until it locks, and it's a hard stop. So whatever it's hitting it's not gradually binding, it's stopped. It's shouldered out or something. I don't know what it is, but somebody said that this thread is an M16 4. That's not what I measured it to be. It's almost exactly 8 threads per inch. And I'll talk about how I measured that, but I don't, if it were just slightly different thread, it would bind slowly, and the friction would sort of climb as you're driving it in, as you're cross threading it. But I think it's an identical insert to this, and maybe what they were talking about was a different model, or they changed it, I don't know. But this threads in way too easily to be an unmatched thread. Now it would make sense that you would want to unmatch it or have it slightly different so that it does bind in and doesn't loosen, but it just goes in so smoothly and then locks, so I don't think that's the case. Okay, so these are my measurements and how I did it, and the way I came up with the pitch is I came in here and measured on the start of one thread to the start of the last, right? And then what I did was got that measurement. Okay, it's almost exactly 0.5, and I'm sort of doing this on camera, but a quick eyeball, it's 5,010, right? So there's half, and if you zoom in on it, it's pretty close. I mean, if not almost exact, to 0.5 for 4 threads. And just looking at the math, right, 0.5 between 4 threads is 1/8 inch per pitch, or 3.175 millimeters, or almost exactly 8 threads per inch, right? So somebody said it's 5/8, 8 threads per inch. somebody said it's M16-4, which would be 0.157, right? So I mean, we're almost 30 thousandths off on our measurements. I can't see it being 4 millimeter pitch. I just can't. I can't see it. A couple other things. So the major diameter here, 0.618. And again, so this is in line with 16 millimeter, and again, they undersized it, you know, so that it's easily threads in and doesn't bind. Now, I can see that, but to me, it's a little bit closer to 5/8 at what, 6.25 or 0.625 would be 5/8, so it's just undersized 5/8, 16 millimeter, however you want to look at it. And then all the rest of the measurements, right? Minor diameter at 1/2 inch or 12.5 millimeters, and then this sort of interesting radius shoulder, which is on the insert itself, so I wanted to duplicate that. So I just took various measurements, right, and then I transferred them to a piece of threaded rod that I got at Home Depot. It's, I don't know, 10 bucks for like 3 feet of it. Faced it off, blanked it out, cut my radius, and then on the mini lathe here, set the gears to run 8 threads per inch. Now, let me just explain how I did that. The feed screw here on the carriage is 16 threads per inch. So that means for every turn of the spindle, I need to have 2 turns on my lead screw. So this posed a problem in the gear set, in that what I had to do was gear my first shaft and my second shaft up to 2. So for every turn of this, I need 2 turns of this. So I have I think an 80 tooth and a 40 tooth gear, right? And then all the rest of these carrier gears don't add in. You have to, with this lathe, you have to gear this up twice the speed of the spindle. And since the motor drives the spindle, you're gearing down to drive the spindle and then gearing back up here. And on a bigger lathe, I can only imagine that this is driven directly off the motor somehow. And that's just not the case here. So you lose a lot of power in all these gears just to turn the feed screw, and it's not plugged in, so I can't show it, but you can just hear it just sort of dogging down. Another thing is that this is just, it's not stiff enough to have the force, the cutting force in, down. It just won't do it. So you can sort of zoom in, and now I did start cutting at 8 threads per inch, so you can do it in theory, but the tool that I made, the tool here, is just too much depth or too much material removal per cut. So what ends up happening is it just kind of squirms around and bends, and then what actually ended up happening, what gave is my engagement mechanism is just this sort of pinpoint in sort of a dimple, and as you could see, it just scored the metal coming down. So I even tried putting shims behind this sort of guide screw and sort of locking it in, and I was kind of expecting that the gears would shear, but no matter what I did, it just kind of kicked this out, kicked this whole setting mechanism in, and again, I have it tightened, so I can't even show you how it works, but essentially this rocks. So in forward, this back gear engages with the teeth back there and this, and in reverse, this one comes up and then just drives through those. So it just couldn't take the stress. So what I could have done was made a really fine, almost like a cutoff tool, to come in and just keep chasing it, and then offset with my compound to sort of walk that back and forth to open up to get my sort of width of the pitch. But you know, it's just not worth, the project's just not worth it to me. I mean, I don't know, it was sort of more of a fun thing than anything. But another thing is, because these are most likely rolled threads and not cut, this is probably face hardened, and you're into the hard material, and again, I could do it if I had all day. I don't. I just thought it'd be quick. I thought I'd cut them. I thought I would throw it together, but it didn't work. So that's the sort of failed project there. Hope you enjoyed it. Thanks.